Hey guys, today I want to cover types of maps. So, first I want to start off with the components of a map. All maps will have a version of these somewhere on them. All maps will have a title, a compass rose, which is just something that shows direction because you need to know which way is up. This is an example of a compass rose right here. A map scale and a map legend. Okay, simply put, the map legend explains what the symbols on the map represent. The scale shows the ratio between actual distances on the Earth and the scale on the map itself. So for instance, on this map that this scale was a part of, 1 inch was equal to 1,485 miles. On this map you can see all four things that we just talked about listed. Here is the title. Here is the compass rose. You can see it pointing north. Okay. Here is the scale down here, and here is the map legend, which tells you specifically for this map the size of the square in relation to the magnitude of the earthquake. Okay, what is a map? A map is a two-dimensional model of a three-dimensional object. The three-dimensional object that the map is modeling is the Earth. Here's some different types of maps you can see here. This is the one that we're going to cover specifically. So we're going to go into a little bit more depth about topographic maps. A topographic map shows several of the geological features that are on the planet. Mainly they show changes in elevation on Earth's surface. Okay. A contour line represents elevation on a contour map or a topographic map. Okay. Contour lines essentially connect points of equal elevation. The contour interval is the distance in height between two side-by-side contours. So if we're looking here, we can see that the contour interval is 20 feet. You can see that here. But you want to be able to know how to find it out. Well, there's two ways to be able to find it out. One, you could do the guess and check method. So you could count each line. You need to get from 700 to 800. So you could count each line to try to figure out which one or which contour interval will get you to 800. While that works, that takes a little bit too much time for me, so I like to do it mathematically. And the way that you do it mathematically is you can look at 800 and 700 and take the difference between them. That would be, let me see if I can get a pin here. Doesn't, maybe. I don't think it wants to. Okay, no, we don't need to do that. Anyway, you take the difference between the two contour lines that you have, the two index contours that you see here. So 800 and 700, you would subtract 700 from 800 and that would give you 100. Okay, then you would count the number of contour lines that there are in between each index contour. And this is what gets confusing when you do the mathematics portion. Okay, so here you can see there's 1, 2, 3, 4. And the biggest mistake that high school students make is they only count this 4 and don't count this fifth one that's right here. Okay, so there are actually 5 contour lines to get to 800 because you have to count 800 yourself. You don't count 700 because technically that would be 0 on a 0 to 100 scale. So if I were doing 0 to 100, it would be 0, 20, 40, 60, 80, 100, or in this case 700, 720, 740, 760, 780, and 800. So I have to include this line when I do any kind of math. So when you're doing the mathematics portion, or when you're trying to use that to figure out what the contour interval is, you need to count all the lines that are in between your two lines as well as the line that you're going to. So once you have that, you take the number that was the difference of this and this, which was 100, and divide it by how many lines you have. 1, 2, 3, 4, and 5. 100 divided by 5 is 20, which is the correct answer here. I mentioned this previously. An index contour is just a contour line marked with the number that shows elevation. Okay, so a closed loop of contour lines indicates a mountain or a hill. You can see this here. if this was the model that we were trying to represent, turned into a topographic map showing contour lines, you can see that the hill here is a closed loop of contour lines. One of the things I'm going to try to trick you on your test is contour lines never cross each other. I'm going to give you a map that has two contour lines crossing and ask you what's wrong with it, and there's your simple answer. Depression contour lines, we won't see these very often. However, I do want you to know that they show some features like holes, mines, volcanic craters, anything that sinks down into the earth. So depression contours are different from normal contour lines because they have short lines attached here. That shows that the earth is depressed at that point. Another thing you need to know is that how close contour lines are represents the steepness of the slope. If contour lines are close together, that means the slope is steep. What I mean by steep is that it goes up at a high angle. Okay, so this is steep versus gradual, which would be like this. Okay, so steep, gradual. Okay, and widely spaced contour lines indicate a gradual slope. Okay, here you can see contour lines of these two structures. Same thing here, and we'll do an activity like this in a couple days where you will be required to make something that sort of looks like this image here. Same as this one. All right, thanks guys.